We need the system to be as robust as possible. So we are speaking about a clear connection between the two interfaces.
Welcome back to Parker Hannifin's manufacturing location in France. I'm Alice, and today I'm joined by Amir, and we're talking about creating reliable cooling connections in data centers. So Amir, what is a reliable connection, and what should our teams be looking for?
Hello Alice, thank you for your question. Of course, today we are seeing more and more adoption of direct liquid cooling on the new data center today. And I must say, when I speak about reliability, the first thing I think is about no leakage. So today, customers are first request the connection has no leakage at all.
For today's data center cooling, what are our top 3 requirements for reliable connections?
No leakage, that's the first thing. Of course, this needs to be easy to connection. This needs to be easy to scale also on the production. We need the system to be as robust as possible. So we are speaking about a clear connection between the two interfaces. And of course, we will focus also on the cleanliness of each component to make sure when the system runs on a closed loop, we have no contaminant inside the system.
And when you say robustness, what does that mean?
Life cycle, that's the first thing. Customers are coming to us asking us for all the tests we done before. So connection, disconnection test for our coupling, also for our hose. So life cycle of the hose, yes, and how this will end during the total life of the data center. So that's the top 3 things we'll have, and of course cleanliness.
And if we're advising engineering teams, what are they looking to prioritize?
All the tests we did before make clear that all the flow, speed, they came to us and asked us, yeah, here's the flows we need to hide for. So the direct liquid cooling today will ask us to increase the level of liquid on the circuit, so we'll have more and more of that. So as I say, no leakage, that's the first thing. Came to us and asked what is the level of spillage we may have on the disconnection, the highest level of cleanliness on the market. It's required, but the top point.
I hear you say cleanliness is important for us. Why is it so important when we're talking data centers?
Oh, it's so important because, as I said, it's a 24/7 system, so customers don't want at all to stop the system. When we speak about cleanliness, of course, it's water, and there's some risk on the system where you may have some metal particle. To take care of that, we have clearly escalated this risk and our requirement to our supplier with the raw material. So the raw material is clearly took, and we look at how critical the cleanliness is at the very beginning. So with the raw material, we avoid to add any contaminant during the production, of course. And at the end, we are also cleaning the component. For example, for our manifold, we make some specific cleaning process. And before to ship the component to the customer, we make sure also we add some nitrogen to make it pretty clear. And we have also some specific packaging. So when the customer receives it, there is no contaminant inside.
Perfect, and that's super important.
That's super important.
Final question. So back again for our engineering teams and what advice you'd give them. What should they look to verify, to validate evidence that this has been done?
Of course, they will, as I mentioned before, the critical point will be reliability. So they may come with a specific requirement on reliability, on spillage, on cleanliness. But what I say also to the engineering team, please come to us and discuss with our product manager and engineering team, trying to establish the best solution to their application.
Perfect. Thank you so much, Amir.
Thank you, Alice.
As we've seen, reliability isn't just a claim. It's validation evidence, cleanliness, and robustness. From cooling to planning, join us next time for Parker's next Insight to Impact as we get architectural. See you then.